Welcome to our session on robotics and the opportunities for everyone to become involved in robotics. We have two panelists here. First is Rahal. She's a PhD researcher, and her resume is on the website. And we also have Chris Yonker, who works at Jet Propulsion Laboratory, and he is very active in the field of robotics and entered the field a little bit later in his career. So we have both ends of the spectrum here that represented this morning with a researcher as well as a practitioner. We had a third panelist who unfortunately had business commitment, business crisis come up this morning. She works for Toyota and has a production issue she's dealing with. So the two panelists are aware that they've got a little bit of heavier load to carry, and I think we'll get some great perspectives from them this morning. We've been chatting a little bit before the session started about careers and how careers the life takes you in a different spot than you'd likely anticipated when you entered mechanical engineering. So I have a couple opening questions that we can start with, and then we can open the floor for additional questions and keep the conversation going and answer some questions about things that you might be worried about as a student entering the field of robotics. So Rahaf, if you could start the conversation for this morning and tell us about the kinds of robotics problems that you were involved with in your research. And how did your background in mechanical engineering help you with your current work?
Okay. Hi, everyone. So to talk a little bit about my research, I'm currently working in designing new shared control methods for robotic teleoperation. So for those who don't really know what it's about, teleoperation is usually, it encompasses a system where there's the user, the human user, which tries to control a robot from a distance. For example, in applications like robotic surgery, or even to send a robot to space or an underwater vehicle. So what I try to do is design some shared control methods for this system, which means that we share the control of the system between the human user and between the autonomous system. And to do that, we use some haptic information, we use some vision systems as well. And I think that my mechanical engineering background helped me a lot in my work, because all of the notions that I learned during my bachelor's and my master's degree, I mean, I use them a lot, like starting from the mathematical background to even the kinematics, dynamics courses, the control systems, electronics courses. So I think that my background in mechanical engineering helped me really get into robotics and work on the research problems that I currently work on.
Well, thank you very much for that opening. I appreciate that. Chris, how did you did not start your career in robotics or space exploration? How did you get to where you are today as head of the Extreme Environmental Robotics Program at the NASA Jet Propulsion Laboratory?
Okay, yeah, so I studied mechanical engineering in undergraduate and came out knowing that I wanted to design things. And so I ended up, I went to school at North Carolina State University, graduated, moved up to Maryland and joined DeWalt, designing power tools for several years. And that started to introduce me into more of electromechanical engineering. So I was specifically doing printed circuit boards and motor development for the power tools. A few years later, I moved back to North Carolina, ultimately ended up in consulting, which broadened my perspective into numerous different engineering problems as well as different fields. And then in about 2008, 2009, iRobot decided to get into maritime robotics. And I had done a master's degree in fluids. It was kind of an electromechanical system. I came over to iRobot as a mechanical engineer doing underwater vehicles, and quickly took over as the chief engineer for the entire division, where I now had systems, electrical, mechanical, and software engineering under my purview. And so that really got me into robotics, and I've kind of stayed with that ever since. So for the last 12 years or so, I've been there. A little over 5 years ago, I had already moved out to California, was looking for another opportunity, ended up at the Jet Propulsion Laboratory, designing robotic systems there, and then took over as the group supervisor for extreme environment robotics a couple years ago, and have continued to grow and expand in that area with people that are working on all sorts of different robots for planetary exploration. So it's been a great career, and lots of pivots along the way.
Chris, let me just ask a little bit of a follow-up question that I've been thinking about this morning. The extreme environmental requirements for the robots it must touch a lot of your other mechanical engineering training. Do you find that there's any areas where you wish you had additional training at the undergraduate level that would have prepared you for your job?
Definitely, one of the things that we see all the time is the undergraduate programs just don't give enough depth into robotics. So if you look at a robotics, system, it is not just a, mechanical system. It's not just a motor and a gearbox, for example. You've got software, you've got control systems, you have sensors, you've got behaviors, and you got to kind of understand how all those things need to play together. So if there's anything that, I wish there was more of at the undergraduate level, is more of that systems approach and understanding, when you have to take your, one electrical engineering course in your mechanical engineering degree, sure, you learn Ohm's law and you learn the basics of how to deal with the resistor network, but you really don't understand how that applies and how even in a mechanical system, the electrical engineering or the software engineering, the controls engineering all needs to play into that in order to make a robotic system successful. But that's why there's graduate school. I mean, a lot of our people do go to graduate school either for a master's or PhD, where you can really dive into more depth into those subjects and broaden your knowledge base.
Thank you for that. I've got one follow-up question. I'll get back to you in just a minute. Rahaf, how do you, what has been your experience as well from the undergraduate level to prepare you for your research?
Yeah, actually, I agree with Chris. So basically, in my undergraduate degree, most of the courses were general courses. So I took some courses in electronics, some courses in mechanical engineering, others in programming. And I think that it gives you really what you need, the general idea of what you need in order to enter robotics. But robotics is really a multidisciplinary field where you have the system components are really varied, from the software to the hardware to the electronics. So I really think that it prepared me, of course, but also I needed to explore more and to learn more throughout my career after. So during my master's degree, for example, I went more into the vision side. I learned some computer vision, some coding, some programming. And during my PhD, I also had to go more in depth about the different topics, such as dynamics and really robotics theory. So I think that a bachelor in mechanical engineering helped me a lot. It gives me the tools that I need, but also I needed to keep learning throughout my master's and my PhD.
Excellent. And Chris, the follow-up question I have for you, and with your employment history, did you find that your employer was supportive in additional training for you, or was it all on-the-job training to pick up all the specialty considerations in robotics design?
I've had a mix of it throughout the years. Certainly DeWalt paid for my master's degree, or at least most of my master's degree, which was helpful from that perspective. The Jet Propulsion Laboratory, we're a part of Caltech, so it's an educational institution, so there's constantly opportunities to continue learning. Now, when I worked for startups and stuff, there wasn't money necessarily to send people to training, just due to the financial constraints. But I have a professional engineering license in 2 states, so I have educational requirements I have to do every year. But I was able to negotiate with my managers in those cases to say, look, I will pay for my training class out of my own pocket if you will just give me the time off work without having to use vacation or other things. And I've never had a problem getting that negotiation to be successful, and it's enabled me to continue to build my skills and continue to grow. And robotics is constantly changing, so whatever you learn today, you're going to have to learn something new tomorrow in order to keep going and be successful in the field.
Absolutely. Rahaf, in terms of your research, do you see applications across multiple industries for robotic applications? Are you focusing just on medical? I'm just trying to develop the notion that there are so many opportunities in robotics in multiple industries as well. So any comments there?
This is definitely true. So really, robotics is entering every aspect of our society. It has many applications. Now, in terms of my current research, I worked, as I said, in teleoperation. So the main domains of applications are, let's say, robotic surgery, the medical side, also the robotics exploration in space or underwater, as well as maybe nuclear decommissioning, where you cannot have the user physically present in site. So other applications that I've also worked on are mainly in industrial applications, so automation of the industrial robotics in order to pick and place objects, for example. So I really see robotics going into every aspect of society, as well as, of course, social robotics, for example. They're gaining more and more importance nowadays. So robotics need to interact with people, and this is another application that I think is an important one as well.
Excellent. And that's many of the same conversation that we've had at the leadership level with ASME about the multiple applications of robotics in many industries. Chris, if I could turn to you just a little bit, in terms of your career development, and I want to explore just a little bit about whether or not you've had a mentor or used multiple mentors in your career to help shape your career, kind of benchmark where you are, and opportunities for moving into different areas in the field. Any comments on that question?
No, absolutely. I've had many different mentors over the years. Everything from, occasionally I've had really good managers, direct line managers that have been interested in my career development and have provided opportunities. Oftentimes I do seek out somebody external to my direct line management to provide advice and guidance along the way, because oftentimes you don't always see, what your career path opportunity is. And what that might look like. So having somebody that, if you see a job posting come up and you say, hey, I'm interested in maybe doing this, that you can bounce off of, get a different perspective. It's been immensely helpful to be able to steer and go in different directions. And, and I've never been afraid to take a step back sometimes. I mean, I've certainly had jobs where, I've had a really nice salary, but then I've taken a major step back just because it was interesting and I wanted to do something very different. And, as I pivot my career, I've always managed to regain, those things in terms of salary and benefits and other things along the way. But it's helped me to be more fulfilled and broaden my background. And, a mentor has certainly been helpful to help make those decisions and guide through those processes.
Excellent. Yeah, and certainly in my own career, there's been times when I've had to take a risk, take a pivot, and look into areas where my comfort level was not necessarily there, and found that by taking those risks, you actually advance your position. And I sure appreciate your comment about making up for the salary and the progression by taking some of those chances. And Rahaf, in terms of your thinking of the next steps in your career, have you given that much thought yet? Any idea what you might be looking for when your research is completed?
Yes, so after my PhD, I would like to stay in research. I enjoy this research part where you have to find new problems to solve in a new kind of way. So what's nice about a PhD is that it opens opportunities in different types of industries. Like I can go to industry, I can stay in academia, I can do a postdoc. And I think the next step would be maybe a postdoc also to continue working along the line of my research. And then I think there are multiple opportunities for me, which I think I will embrace at the time.
Absolutely.
Yeah.
And I think you're going to find it in this program today. There's other areas of discussion about the use of LinkedIn, and use of networking, all tools that people can use to enhance your career. And I would encourage you to listen to those as well. And then now back to Chris a little bit. From where you see, and we've just talked about pivots a little bit, do you expect to spend your entire career in robotics?
That's a good question. I get asked that. My boss likes to ask me that question frequently. I don't know, because I'm coming up, the longest I've ever worked somewhere was 7 years. That was at DeWalt. I'm pushing on 6 years at JPL now. So, but I don't know what's next. I spend a fair amount of my time actually supporting the National Space Technology Applications Office at JPL, which is how we transition technologies that are developed for NASA and for research into the marketplace, and how do we get them out into the world, whether it's through commercial licensing or through partnerships. And I find I really enjoy that. I've got a long history in consumer products and in the industrial side of things. And so it may mean that, eventually I move more towards a program management type role where, looking to seed more of those partnerships and that type of stuff. But I love robotics, so I think I'll probably stay close to robotics, but what the nature of my job is very likely to change over the next 15, 20 years still.
Excellent. And back to Rahaf, help us a little bit understand your perspective on what is the most important thing you learned while working on your robotics research.
Yeah, so one important thing that I learned is that robotics is complex. So it's a system which is composed of many elements. So I think that's something we need to keep in mind, is that it really needs to be put in a way which works together. So you cannot just work on the software without having the right hardware, without having the right sensors. So I think the robotic system should be complete. And it's not always trivial to put all these elements together. So I think this is one thing that I learned. And also to always learn the new things that you need in order to do robotics. Because as I said, it's multidisciplinary, and even though you know how to program, for example, it's also important to understand a little bit the mechanical components. So I think this holistic approach to robotics is something really important.
Excellent. Thank you for that. I have another question for both of you, and I'll flip back to Chris on this one. Are there opportunities, and I'm playing the ASME card just a little bit here with this question. Are there areas where you could see additional collaboration with ASME in the technical aspects of robotics to help advance your career? Are there areas of opportunity where additional programming, conferencing, advanced learning and development classes might be of interest, Chris? And then I'll ask Rahaf that as well.
Absolutely. I think everything is a continual learning. Robotics is a developing field. It's changing rapidly, so it's important to continue to learn. I would like to see ASME offer more opportunities to take education within robotics and stuff. And understanding that, it is a multidisciplinary, area, and that, it's not just about, can you design a great gear train? That's just one part of the system. And so for ASME to, expand their offerings in terms of, electrical and controls and the software side of things that, aren't your traditional mechanical engineering things, but are so critical and key to being, in these multidisciplinary fields, is an area that I would like to go. And, I think ASME is a little behind in that area. I think IEEE is actually more ahead in that area, but ASME is making great progress. It's starting to offer these things. And what's important is for everybody to take the opportunity to continue to learn and develop those skills, regardless of whether it's coming through ASME or other institutions or opportunities that are out there.
Excellent. Yeah, I would agree with you wholeheartedly that ASME has been late to the party on robotics because it is truly such a multidisciplinary approach, and as technologies has advanced, that has become even more obvious. And I know ASME has one group right now that's looking into prognostic health management of systems and looking at failures of various systems, including those that are operated and enhanced by robotics. So that's one area that we think that we can enhance both the student and the practitioner's experience in the robotics area. Rahaf, do you have any other perspectives on that question as well?
Yeah, I think so. As you already said, I think that maybe the collaboration with other types of societies that work on robotics. So usually ASME deals more with the mechanical side of robotics, but maybe opening this to more programming experience or maybe systems engineering as well would be nice.
Absolutely. Hey, I'm actually the questions have gone pretty fast, and I'm ready now to take any other questions from the audience. If anybody has any other additional questions they like to ask these panelists, Nicole, I'm not sure if there's anything that you might want to add from your experience.
Sure. So we have a number of questions coming in. I guess the first one that I'll ask to the entire panel, how do you see machine learning affecting the field of robotics?
I can take a stab at that. One of the big areas of robotics that's a developing area is the notion of autonomy and AI. So I think Rahaf has talked a little bit about where there's the human in the loop type of thing, and you've got haptic feedback and you have other things in the system. When you look at some of the stuff that we do, in the space exploration, human in the loop really doesn't become a great option because the time to communicate with a system that's say on Mars or, flying around Jupiter or out even as far as Pluto is on the order of minutes. I mean, it takes 45 minutes for a radio signal to come from the furthest end of our solar system back to Earth. And, that's a one-way trip. And so if you're talking 90 minutes back and forth to control something, that's intractable. And so autonomy and AI is one of the big places that we're going. And machine learning is a big part of that. So, you want the system to be able to make decisions for itself. And so being able to, take like some of the work that Rahaf has done in like computer vision, for example, where you may see something, in your camera, well, you want to be able to then match that to maybe a known object or a known set of objects of what you have that you've trained the system to be able to recognize then and make decisions then based on what you want to do with that. So you might say that, oh, there's a particular rock of interest and the scientists have told me if I see that particular rock, then I want to get a sample of that rock. And so then you can start to stage those behaviors and use the machine learning to give you some of the feedback and make the system a little bit more adaptive and autonomous in its operations in order to remove the human out of the loop and reduce the time that you have to wait for the next command and allow, in our case, more science to get done in a shorter amount of time.
Rahaf, anything to add?
Yeah, I agree. I agree that machine learning is really a tool that's being used a lot in robotics right now because what really, I mean, is that the robot can overcome unknown situations, for example, and this is usually the human capacity that can make this happen. So teaching the robot how to do this autonomously using machine learning is a great way to advance robotics.
Another question we have, and Rahaf, I'll ask you to start on this one. A lot of questions about, do we need advanced degrees in programming, dynamics, mechatronics, or other robotics? And do we really need to commit to an advanced degree to get a job in robotics?
I don't think so. In my opinion, it's not really a necessity. So the more advanced degree, the more you are specifically qualified in a certain branch of robotics. So if you learn mechanical engineering as a bachelor's degree, for example, you can easily learn more in the industry later on if you get a job. But if you would like to specify your knowledge in a certain domain, like in my case, I really wanted to get more in depth into robotics. I decided to pursue some graduate studies. And in terms of, for example, programming, I started with just one course of programming in my bachelor's degree. And then eventually I just learned that by myself. So I think also these skills can come by themselves as you need them throughout your career. So I think if you would like to pursue more detailed, a detailed degree in a certain topic, then yes, you could continue graduate studies, but it's not really necessarily on what you would like to do later on. That's my view of things.
Maybe I'll counter that view just a little bit. So I hire a lot of people into my group at the Jet Propulsion Laboratory, a lot of students. And there are a couple of things that, we do look for. Out of maybe, every 10 or 12 students that get hired straight out of school, only one gets hired with a bachelor's degree. And that is because, for the work that we do in robotics, the bachelor's degrees don't provide quite enough depth and background into the different areas. And so we do look for people that have, gone to a master's degree or a PhD and dug a little deeper into a particular area. The one exception that we get to that with the bachelor's degrees tends to be people that have been highly involved in different things. So people that, got involved in FIRST robotics in high school and really took, key roles in those competitions, in designing and developing the robots and maybe moved around to get that systems perspective. People that have been actively involved in robotics clubs in their colleges and universities are ones that, tend to bubble up to the top that, they've gotten that experience somewhere else other than through an educational program. But a good mix of those things is certainly one of the strongest ways to get your foot in the door to this industry and to be able to make a successful career there. And a lot of people, most of my people that have bachelor's degrees do go back to school and get an advanced degree within a couple of years usually.
Chris,
And I
that
think
was
there's-
an excellent, go ahead.
Go ahead, Rich.
That was an excellent perspective, in terms of, some careers that where a bachelor's degree gets you in the door and get you operating, without too much supervision, whereas, the more focused and those practitioners that come in with some greater experiential learning, like FIRST robotics, I think is particularly interested. Do you see any particular skill sets or focus at the undergraduate level that would direct students to a robotics career? From either of you panelists, I'm just trying to develop the point about is there a particular skill set that could help identify a path in robotics?
Definitely. So especially in robotics, anybody at the undergraduate level, if you get the option to take elective courses or other things, to take courses in mechatronics, take an extra programming course, take a controls course. You'll probably take one as a part of your degree anyway. But if you go and dive deeper into the controls, you begin to get more of that, system level kind of multidisciplinary perspective that is so key to robotics. If robotics is where you want to go, don't take another, thermodynamics course. Don't take another heat transfer course. I mean, those are not, there's a place for them, but it's not the driving key into getting into a career in robotics.
Okay. And Rahaf, any comments on that one?
Yeah, I agree. I agree that there are many courses in my bachelor's degree which I would have liked to take as well to go more in depth in some details. And maybe also I would encourage students to participate in some workshops or competitions, even if it's not really in the curriculum, but maybe to try and learn more from outside. Because, for example, ASME used to have a lot of workshops during my bachelor's degree and some design competitions and some mechatronics workshops, things like that. I think also they add a lot and you learn a lot from them.
Absolutely.
Are
Okay,
there
Nicole,
any
do you have
others? Yep. Are there any other, say, self-study resources or blogs or podcasts, items that you follow for someone who's interested in this industry and wants to either increase their own knowledge of the industry or to advance their knowledge without pursuing, say, a formal degree.
I may maybe add that so right now there are a lot of online courses which are easily accessible for students. For example, I took some machine learning courses online, which were really beneficial for me. So I would encourage students also, if they don't have a certain course in university, to try to find it online. I think there are many resources on that.
Yeah, I think, the internet has been an amazing thing, watching that develop over the last 25 years or so. And the opportunities are abound, but there are things, I think Rahaf mentioned some of them, but, like the hacker days and stuff, if you want to improve your programming skills, go participate in a hackathon. That is going to skyrocket your skills very quickly, and you'll learn from others around you. The maker movement that's going on today is just incredible, the opportunity to, be able to see the things that are in your mind come to life, so quickly as you develop stuff. And so, any of those opportunities, to just go and do those things is just going to help to make you better and better at, developing those skills.
Great. What qualities would you consider the top qualities or characteristics of a good robotics engineer?
Okay, qualities. I would say the ability to keep on learning, maybe also patience, because really to let the system work, it requires a lot of patience and perseverance. And also, I mean, the most important for me would be to keep on learning. You learn a lot throughout your career. It's not really something that you learn once and that's it, you use it everywhere, but it's a continuous process to be open to new possibilities, to new ideas.
Yeah, and I would say the other thing to build on that is, having a good systems perspective. So, befriend your software engineering classmates and your electrical engineering classmates, and learn what they do, and learn how their stuff comes together to make a full system. And then, from a mechanical engineering standpoint, we hire people that have, good hands-on experience. So, I mean, have you actually built something? Have you built a mechanism? Even people that go do like Formula SAE and stuff, the ones that do like the suspension systems, we can directly take that experience and apply it to developing mobility systems for robotics. And so anywhere that you're able to, really get the thing, I mean, as Rahaf said, you put these things together, they oftentimes don't work the first time. And so the patience to go through it and the understanding and the things that you learn when you go, oh, I should have made that a clearance hole instead of a line-to-line fit type of thing, comes back to play, and it helps to make you a better engineer and, in our case, better robotics engineers.
So earlier we had a discussion about whether or not you need an advanced degree. The question is, what it would be considered, and how do you find an entry-level robotics job?
That's a great question. I think, it really comes down to interest with things. And sometimes, starting, there's lots of small robotics companies out there today. So like, I'm at a national laboratory, it's much more of an academic type of institution. There's certain things the institution looks for in order to hire people in there. But there's a lot of startup companies out there. And so, being able to go in, get experience with that, look at the whole parts of the system. 3D printers are a great example of, kind of everything of a robotic system is there. It's just not really put together as a robot. But if you got on with, say, a 3D printer company and learned, all the nuances of, how do you do the control systems? How do you do the stepper motors? How do you set up the mechanical systems for that? It's looking for those things of, what are the building blocks that you can use to keep building on that educational foundation that you got to improve those skill sets so that, you can make those transitions over the years to get closer and closer into a true robotics position.
And I wish Jamea were here, to talk about from the manufacturing perspective, because exactly, it is a lot of those control systems and, not necessarily the traditional robot, but the automation of those processes that uses a lot of the same systems thinking and design skills as I think what people more traditionally think of as robotics. Rahaf, do you have any further comments on that?
No, I think that Chris already said everything about that.
Okay. A fun question here. What pet projects do you have at home to help you advance your learnings in robotics? Do you have any projects at home that you work on, like Arduino controls or stuff like that, to practice and to advance your skills?
Rahaf,
Yeah.
you want to take a stab at that first?
I'm gonna start, yeah. So during my bachelor's degree, actually, I had a lot of projects going on, like Arduino projects, mechatronics projects, which helped a lot. This is actually how I started getting interested in robotics, because when I entered my bachelor's degree, I was not really sure which track to go. I was interested in mechanical engineering as a whole, but then when I started doing these projects for whether it's for university projects or even started building things myself. This is how I got more interested in systems and robotics and seeing how things can actually work from set of just small systems with some code. So actually, I think that doing some side projects is definitely important.
Yeah, and I think for me, I've got a mix of projects that are going on all the time. They're not usually in robotics necessarily, just because, once I spend 45, 50 hours a week working in robotics, sometimes the last thing I want to do is actually deal with a robot when I get home. I've got right now I'm doing an upgrade on a milling machine in my garage to make it CNC. So, going through, kind of all the programming and everything required for that. I do have an Arduino laying around, and my big goal for this next year is actually to put a bunch of animatronic Halloween props in my front yard. And so I've got lots of things, swirling around that, I plan to start executing on here in the near future to start building and getting ready for next year.
I have a friend, actually a fellow Wolfpack NC State alum, and that was exactly how she got involved in automation and controls, and was exactly that, making basically a wholly animated front yard Halloween display, and it's a great way to practice those skills. And she directly used that in her job application or her interview as the examples that, of things she's learned in the industry.
Yep.
So another question that we've received on getting started in the industry, given the kind of difficulty, say finding a true entry-level job in robotics, is it easier to transition into robotics from another industry? And if so, are there certain industries that lend themselves better to doing the transitioning into robotics?
I don't have a lot of industry experience. Maybe Chris can answer that.
I would say that is, there are multiple paths obviously to get into robotics. So, the educational track is one of them. If you want to land into robotics eventually, but, come from different industries, then, the key is going to be making sure, again, the broad skill sets. So how do you get in? Like for me, I graduated with my mechanical engineering degree, and I swore off electrical engineering. I want nothing to do with it, ever in my life. I ended up in an electromechanical engineering group at DeWalt, and here I was designing printed circuit boards. I was designing motors. I found that I had to learn the electrical engineering side of things fairly quickly. And once I saw how it worked in application, it suddenly made sense to me. It wasn't just a textbook of what is his Norton's equivalent type of thing. And so being able to take and look at those opportunities, I think Rich said it before, stepping outside your comfort zone. Hey, I don't know much about programming, but I'm going to go work on this project that's going to require me to do some programming because it's going to force me to learn that skill set. And as you begin to pull those things together, Nicole, you talked about before, you can start to put those in the hobbies, you can do other things. And then when you go for that job interview and you can talk about, well, yes, I built this and I had to program it and I had to debug this electrical issue. And, all of a sudden it's like, wow, you've got that systems perspective that can make you a good robotics engineer and you can break into the industry.
That's great. So a very interesting question. this is, I think, something we're seeing more so on drones, but how are government policies evolving that affect robotics field development?
Definitely in our industry, I mean, I'm a contractor to the US government. So we've seen various different things with that. For example, we are absolutely prohibited from buying or using DJI drones, for example. And so, anything with that, a lot of the, your lower cost electronics and motors and other things come out of China. And so there's a lot of concern with that in terms of, espionage and other things that can be built into those things. And so it has had an impact on the way that we go about things. And it's forcing us to take a look at, the US wants to lead in these technology areas and the development of these things, but how do we do it in a cost-effective fashion? And how do we make sure that U.S. industry or other countries that are friendly to the U.S. Are structured in such a way that we can get the parts and components that we need? And so it is leading to a lot of creativity. I think this is the reason why you're starting to see like additive manufacturing technologies developing for like printing circuit boards and being able to do integrated type of stuff. Is that if you can be able to fabricate your electronics as a part of building your initial robot. And do that in a very vertically integrated structure, in your own lab and other things, you take out that need to be able to, bring in a foreign supplier that can open up risk and import export control problems and other things that might go with that. And so I think it's going to be interesting to see how this, continues to develop over the next, decade or so in terms of the rapid manufacturing, the additive manufacturing, and where do we go in terms of U.S. infrastructure in order to support robotics and growth in those areas.
Rahaf, anything internationally that you're seeing?
No, that's really not my topic, but I would add maybe also that there are some ethical concerns which are being used from robotics, like surveillance, like getting into the privacy of people. So I think this is an important aspect, but I'm not very familiar with the current rules.
So I think we have a participant who's maybe a little bit worried that we'll have a Skynet type issue. What concerns should we as a society have about the advancement in robotics automation, particularly when tied to AI?
Yeah.
Rahaf, you were touching on that before.
Exactly. So I was trying to say that ethical concerns are definitely important. There needs to be rules which really control this aspect, but I also think that in the end, I mean, it's us who are coding these codes. So I think, yeah, so as long as there are these ethical concerns which are taken into consideration, I think it's fine.
Yeah, and I would agree. There's going to be the ethics of it. There's going to be regulations. We've seen some regulations, here in the U.S., that have kind of, whipsawed back and forth a little bit. Drones is a great example where the FAA a couple years ago said anybody that flies a drone has to go get a license, a pilot's license, basically for them. And that's kind of swung back a little bit now to say, well, only in certain applications and certain size drones. But even like here in California, we see it all the time, where people fly drones over wildfires. And, and when they do that, then the helicopters and the aircraft can't fly to go, work on fighting the fire. And so how do we get into, the controls of that? What are the regulations and how do we communicate those regulations? There's a long ways to go. It's still the Wild West out there in terms of, how these things are being adapted, how these technologies are being put to place. And I think it's really on all of us as engineers to remember that, our job as an engineer is to, be there as a benefit to society and to help make society a better place. And so understanding our ethical concerns, bringing that forward, linking with organizations like ASME and IEEE and others that, write the standards and regulations in these areas, participating in those boards and being a part of that is what's going to help to drive the industry forward.
So Chris, since you just mentioned about participating in professional societies, are there other ways that participation in your professional societies, such as ASME or IEEE, can help to advance your career in robotics?
Oh, absolutely. Networking is one of the key things. We were talking before the panel started that, at the Jet Propulsion Laboratory, we receive between 10 and 12,000 resumes a month. And so, we're only hiring for maybe 100 positions at a time. And so you can kind of see like getting your foot in the door, networking is the key to that. So, participating, at your local level, if you want to stay in the local area, helps you to get into different areas. I mean, I was on the board of ASME's section in Baltimore for many years. I was the chair of the board in Eastern North Carolina section for many years. I've continued to be, participate in things here in California and stuff. It just gives you a greater exposure. And, even if robotics isn't where you want to go, you get to learn about all these other industries that are going on. You get to get a tour of a manufacturing plant and go, oh my gosh, I never thought that that's how you actually, build that thing and put it together and the processes that go into it. And so you just learn so much, and you can take that. And then, if you are looking for a change of a job or something else, it's nice to have those contacts that you can call up and say, hey, do you know of anybody that's looking, or anybody that's hiring? Because I'm interested in making a change.
My husband still talks about the tour of when you were working at iRobot as one of his favorite ASME professional section meetings. Rahaf?
Yes, I would add to that definitely networking, and I would add also the technical workshops and the conferences that I attend, for example, in research. It's a great way to know what other people are doing, to get inspired, to discuss your work as well. So I really think that's one of the main advantages.
Well, Rich, we're just
Yeah,
about a minute.
I was just going to chime in. My digital clock is telling me we're out of time here. And I think this was I took away more from this session than I added. I can guarantee you that. I think the messages for the people watching this is this is a great discussion on how careers are formed, and how one path will lead to many others than a successful mechanical engineering career. And the message that I continue to hammer when I'm on the podium talking to students is the networking aspect, and keeping working outside your comfort zone. Don't get particularly comfortable with a particular position. Follow your dream, and things will happen, and you need to have confidence in your ability. I frequently tell the students that the biggest asset you have when you graduate from your undergraduate degree is the ability to critically think, and certainly the two panelists have pointed this out, and in great detail, and as have some of the questions. So. With that, Nicole, I think we need to keep you on schedule, right?
Absolutely. So certainly want to highlight that there are additional sessions occurring in this hot industries track. So our next session in this particular track is the space panel, which starts at 12:30. Starting now at 11:45, we have an interactive interview simulation that I highly recommend, where you can actually choose how our interviewer and interviewee answer the questions. So I look forward to seeing everyone over in one of our other sessions. And thank you so much to our panel for your participation today.
Thanks for having us.
Thank you.
Thank you very much.